Hello, everyone. Since our second exam is postponed to next Tuesday, we will continue a new chapter, chapter 5, project, appraisal, and loans. Starting from chapter 5, we begin to see the application side of this course, right? From chapter 1 to chapter 4, we pretty much laid down the foundation. In principle, we studied or we spent a lot of time studying interest rates, various ways of expressing interest rates, discount rates, those are closely related. And we focused mostly on pricing annuities, right? That is, we compute the present value and the accumulated value of various annuities. Those are the fundamentals. Using those knowledge, we are able to solve some real life problems we always face. Here in chapter 5, I give you a quick overview of our objectives of this chapter. They are basically three. The first one, we want to compare different business projects and select the best one to take. This is very, very realistic because usually for many companies, there are different projects available, right? But due to the budget concern, it won't be able to undertake all the projects. It's very likely that the company has to pick one or two, right? The best one or the best two. How does the company make the decisions, right? Here we are going to apply the so-called net present value framework. So this is the so-called NPV. Let me go to my usual color. So this is what we call the NPV method. That is the first objective. In the second objective, we learn how to assess the performance of different investment funds. Okay. For instance, once you get a job, you will need to deposit some of your earnings into the retirement account. You have some kind of control over your own retirement account, not full like a freedom of picking stocks, but you can choose different investment styles. Meaning you can go something, let's say market based. You can pick large cap market index. There are many companies or mutual funds that start portfolios to track the market index. There are so many funds available in the market, right? What would be an ideal choice for you to pick, right? For instance, there are many funds tracking SP 500. Should you go with Vanguard or Schwab or iShares, or there are just so many companies, right? They are doing the same thing. Which one is better, right? That is slightly a easy task, but there are more difficult questions you may want to ask. Is there are some funds that are highly attractive in the sense that their past performance is outstanding, like 30% annual return, but they can be very risky, right? Nothing comes, free in the financial market. So higher return means higher risk. And there will be some funds that mainly invest in the bonds, in the treasury bills. Those obviously can't deliver outstanding performance, maybe just the 2% annually, but they're very, very safe, right? There's less likelihood that those funds would go down. But if you do active investment in highly risky assets, like many stocks are highly risky, right? They could give you outstanding return, but the future is somehow uncertain. Okay. How can we assess the performance becomes a very important topic, right? Here we have two key terms. Those are time-weighted interest rate and dollar-weighted interest rates. You can think those as returns as well. Okay. In the last task, we study how loans can be repaid. Arguably, the last one is probably the most important one, because throughout our lives, we deal with loans all the time, right? Maybe even at this moment, some of you might have taken student loans to finance your education. You might have taken, say, auto loans to buy a vehicle. In the future, you will, well, most likely get a mortgage to buy a house, right? So there are so many things, that are involved with loans, right? You can even take out a loan to get a new iPhone 12, right? So there are many ways to 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 think of the loans in our daily life. They are pretty much everywhere. We studied two specific methods to pay back the amount you borrow. Those are amortization method and the sinking fund method. So I would argue the last one is very, very important for this course. Okay, let's begin with the first one. 5.1, discounted cash flow analysis. So sometimes you may see these initials, DCF. Obviously, it stands for discounted cash flow. The goal is to analyze different projects, to compare different projects and select the best one. Okay. So what we have here is rather simple, right? So the idea. What is the idea? Suppose now there are many projects on the table. All the files are available. We can take a look. Usually you will see the projected like cash flows, right? Meaning those are expected cash flows. Say you invest 1 million in this project, you are expected to receive $10,000 each year for the next, I don't know, next 20 years. 20 years is not enough, right? So let's make it 120 years. So anyway, the idea is different projects will get you different cash flows. So let's do an easy work. So let's say we have something that that promise to give us, let's say, $2,000 each year for 10 years. Okay, and then we have another one. Okay, it's somehow quite volatile. Let's say it promised to give you 4,000 in the first year, and then gradually reduces. So let's say here you will receive how much do you want to deduct? Let's say $500. Okay, then in the second year I will receive 500. It's probably will get to zero. But anyway, the point is easy to illustrate. Okay, up until, well, then the next one you will get 3K up until, let's say, 1K. Okay, and then it will keep at 1K. Okay, well, obviously those are two different projects, right? And it's rather difficult to just eyeball the payments and decide which one to go, right? Because at the beginning, our first, let's label this as first project, this is second project. At the beginning, the second project seems to be better, right? Because it promises to pay you more, right? So at the first payment, you collect 2,000 from project one, but you collect $4,000 from project two. So if you only look at the first one, obviously project two is better, right? And it is still better for a few years. After that, there will be a turning point, right? At some point, so 4, 5, at year 5, second project will give you $2,000, which is the same as project one. After that, starting from 6, you get 1.5, $1,500, and things are worse for project two, right? Because you only receive for the last couple of payments, you only get $1,000, but project one still gives you $2,000, right? So this is easy, but somehow quite informative example. Project 1 is steady, but the payment may not be to your satisfaction. Project 2 is a little bit risky, and the payments are, promising at the beginning, but it starts to make you a little disappointed, towards the end. Which one do you choose, right? I mean, we can't just directly do a comparison, right? If all the payments are bigger than 2, then obviously the second one is better. But of course, that's not the end story. We still need to take account as how much you need to pay. Right? That somehow further complicates things. Right? Supposedly something more expensive should cost you more, right? But that's not always the case. That's why we need to look at the net value. Right? Net value, it's the key. It's why we have the net present value. So from this easy example, we can form up a principal idea, a fundamental idea is the present value of cash inflow minus the present value of cash outflow. It is the net present value. So if this guy is positive, then what it means is the present value of what you expect to receive outweighs the present value of the money you expect to pay. That means it's a profit to you, right? So you will only take out a project that would end up with a positive profit. So with that in mind, we formally introduce what is NPV, stands for net present value. It is in a nice box, in the textbook, but it's just very, very straightforward. So let me also put it in a box. So NPV equals from 0 to n. Well, suppose this project lasts for n years. It will generate some cash flows, okay, cash inflow. It will generate some cash inflow. Let's put inflow, not inflow s. At time t. So that means that is the money you will receive at small time t. Of course, that is in the future. We need to do a proper discounting, right? Divided by 1 plus r to the power of t. Then this total summation gives you the present value of cash inflow minus pretty much your cost, right? So that would be cash outflow at small time t divided by 1 plus r to the power of t. Okay, if you want, you can further put them inside as net cash flow. So later on, we will just use CF to denote cash flow. Okay, net cash flow divided by 1 plus r to the t. There is no mathematics, right? It's although we did put it in a nice box and with some mathematics. The idea it's very straightforward, right? So it's pretty much what you receive minus what you pay. That is the NPV, right? So of course, since the payments may be made at different times, and comparing money at different times does not make sense. We must convert everything at the same time. For instance, here we convert everything to time 0. That's why we call this present value analysis, right? Of course, you can convert everything to the end of the project. Say here time n, that's the same, right? So that is the fundamental of Section 5.1. It's rather easy, right? But there are many things that require further interpolations. The most important one is R. Before, we simply call R interest rate. Right? R, we simply call it interest rate. So first of all, we should say R and the time, they should be consistent. Okay, consistent in unit period. What I mean is, if all the cash flows are on a monthly basis, so let's say you're supposed to receive something every month, then this T should be the monthly effective interest rate. If you expect to receive some money every quarter, then this R must be the quarterly interest rate. So that's the meaning of consistent. They should share the same unit length in period. Okay, so if it's a monthly payment, then you use monthly interest rate. If it's a quarterly payment, you use quarterly interest rate. If it's semi-annual, then you use semi-annual interest rate. Okay, of course, if it's annually, you just use annual interest rate I. Another understanding is this is not exactly the same as interest rate. That is because projects are often risky. So projects are often risky, meaning that it's not the same as putting money in a saving account. A saving account can promise you 1% return, then by the end you will get 1% return. But many business projects are risky, meaning what you see in the proposal may not be the realization. It may promise you to give you $5,000 each year, but in the end, business can go down and you may end up getting nothing. It is possible, right? So let's say before the pandemic, you bought a restaurant, right? You invest, let's say, 100K into this new restaurant, and according to your business proposal, you are supposed to make $5,000 each month, right? But obviously, after the pandemic, everything's shut down, while you are losing money, right? So all the projects are pretty much risky, and when you do the discounting, what you need to discount by is not the risk-free interest rate, right? You cannot just use 1% to discount a risky business, right? So that is the point I'm trying to make is risk-free interest rate. Okay, they are not the same. They cannot be applied. So I should say this is put versus the opportunity cost. So often we interpret this small r as opportunity cost of capital. So to put it in easy words, so you usually interpret this R as the expected return on something similar. So if say we invest in the bonds, we look at the bond rate, right? So let's say it's 2%, then it's good to use 2% for another investment in a similar bond. Okay. And similarly, if say the expected return of opening a restaurant is 5%, you should apply 5% for when a different person opens up another restaurant, right? Because it is in the same business line. If the location is somehow close, then you should apply the same return rate, right? So in that sense, the most difficult thing, okay, it's obviously there are two difficult things. When you think of a project, One is to project the cash inflows, right? Cash inflows are future income. You don't know, right? When you undertake a project, you can't say for sure how much money you will earn in the future, right? You can only apply some model or apply some previous experience, or the business from a related one to get a rough estimate. Okay, sometimes it can be accurate, sometimes it may not be accurate. So that is the one part. One question is, so Q1 is to project cash inflows. This is not an easy task, right? I already mentioned. The second one is to estimate the cost of capital, or estimate R. Because once you invest in a project, the money is gone, right? Let's say if you want to invest in restaurant business, you need to buy a restaurant, right? So let's say you need to pay 10,000, or maybe 10,000. Let's say $50,000 for a small pizza shop. Okay, $50,000 is the investment up front, right? So if you have invested that amount into a pizzeria, the money is out of your pocket. You cannot use it anymore, right? But if you decide not to invest in this pizzeria, you could well use that $50,000 on something else that also could generate profit, right? So that's why you should estimate what would be the potential benefits for you, right? Different people have different opportunity cost, right? Even the amount is same, because someone may have access to better opportunities. Then money is important for them, because with enough money they can invest in more profitable business, right? But for many people, the access to opportunities is limited. Then the interest rate may be low, right? So it depends. It's my main point is, we can no longer treat this as a constant that is the same to everybody. So I may have a different opportunity cost than you. So that is the two main questions. That is why what we study in this section is extremely important. But in real life, it's not as easy as it looked inside this box, because of those two problems. Q1 and Q2 are really not easy to get a good number. Okay, but of course, once you do, everything else becomes easy. So let's look at an example. Let's assume a company pays $120,000 to purchase a property. Okay, so that is the upfront cost. After that, the company pays $3,000 each month for 6 months. Okay, to renovate the property. Okay, that is actually a very realistic example, right? There are many people who have money and buy old houses, right? With maybe 120K is definitely enough for the stores area to buy a decent house, and then spend 3,000 a month to renovate. Is a good estimate, right? It could do quite a lot of things if you think 3,000 is just the labor work. Okay, it definitely can get many things done, and for 6 months you can probably get a new house, and then you sell it. Okay, and then sell 8 months later for $150,000. Okay, that this number is is a little underestimated, because usually they sell much more than the original buy price. But anyway, it's enough information for us. And here we assume the cost of capital is 8%, per year. Okay, so this is per year, annual. So obviously there's a mismatch, right? 8% is per year, but um, we have some payments which are on monthly basis. Okay, so outflow is somehow the difficult part in this question, right? Because you pay 120K upfront. So let's see. So let's use arrow out to denote it is money out. 120K at 0. This is month 1. You pay 3K. Month 2, you pay 3K, and so on until the end of month 6. You pay 3K, and finally 7, 8. Okay, then you have money in. Well, we can use a different color. 150K. So that is the entire cash flows. Right, inflow is easy, right? So in order to do NPV, so we need to know the present value of all the money we are supposed to receive. So 1 plus 8%. We discount for 8 months. So it's 8 divided by 12. So this is easy, right? And then we need to minus all the present value of cash outflow. So first of all, we are paying this amount at time 0. There's no need to discount. And then we have $3,000. This is a standard annuity, right? It's an annuity immediate. So there are 6 payments. But here, let's put J because I need to know the monthly interest rate. So in order to get J, right? So this is the accumulated value for 1 month minus 1 will give you the J. J is the monthly interest rate. Okay. So then you can do the analysis, right? You can easily calculate this number. Of course, if you want, you can also use this notation can be replaced by 3,000 each month. That means over 1 year, this is the annual payment, right? And this is paid on a monthly basis. So P is 12. So that means this is a P3 annuity immediate. For how long? For 6 months. 6 months is 0.5 year. Right? Again, when we use the standard P3 notation, bar or angle at number, that number would be the number of years. Here it's just a 6 months, so it's 0.5. But I have mentioned many times I prefer this notation, so I always use that. Once you do all the analysis, you will get the NPV is about, what is the amount? After you do all the analysis, it's about $4,896.48. Okay, this is positive. That is good news. We have a nice conclusion or nice result is a project should be accepted if its NPV is greater than 0. This is a very simple rule, but it goes a long way, right? So NPV greater than 0 means you make money, right? So there is a positive profit because NPV is what you get minus what you pay. If NPV is positive, meaning what you receive is more than what you pay. So it should be accepted. But of course, given that there are multiple projects And given that you are likely constrained to some financial power, then you should pick the one that gives you the highest NPV, right? So if you have to choose one, but otherwise anything with positive NPV should be accepted. That is just our rule, but of course in reality, projects come with risk, right? If NPV is too close to zero, probably it's not a good idea to take. In particular, you should consider how much money you invest, right? So in reality, there are many other factors, right? You should also consider the riskiness of a project, right? And the amount of investment. In particular, lump sum investment at time zero. In particular, it's for instance, in this house buying example, you actually need to put down 120K up front, and in the end, you only make this much, right? So it's not a huge deal. It's $5,000 over 8 months, right? It's possible that there are better opportunities, right? So don't just look at this amount. This amount, of course, is important. We will only take a project once its NPV is positive. But of course, if you invest this amount and the return is only $5,000, you probably want to think about it, right? So that's why I put in reality, we actually need to consider more factors. But for this course, we don't deal with this, okay? We actually have another example, so let me do one more example, and then we will close this video. This example 5.1. A project requires an initial investment of, okay, so those are money out, put negative. So this is at zero. The project will generate cash flows of 15,000 at first year, 14,000 at the second year, 10,000 at the third year. Okay, and it's known that the cost of capital is 13%. According to the NPV model, should you invest in this project or not? So let's just do it. Divide by 1 plus r, 1.13. 1.13 to the square, 10,000 divided by 1.13 to the cubic, right? Those are all the cash inflows, right? What you are supposed to receive minus what you need to pay. It's just 50,000. Then you will get, it's about $1,530.70, right? Obviously, this is greater than zero. So according to our theory, since the project has a positive NPV, we should accept, we should invest in this project. Okay, so of course, we always follow this conclusion. Do not factor in your subjective, say, perspective into this. Otherwise, you could well get a different answer, and that answer can be right. But we only take this as the guideline for making decisions. Okay, I already mentioned in reality, we must consider many other factors that are extremely important. But in this course, we put them aside because this is an entry level course. We don't want to talk about the riskiness of a project, and we just look at a simple and hopefully an effective rule. Okay, because if you factor in your own perspective, there are many things you could argue, right? The initial investment is $50,000. There may be some better the maybe saving account or certificate of deposit that gives me 1% or even 2%, then it may generate more money over 3 years, right? Then why do I do this, right? So we have to make our conclusion based on the question, all the information from the question, and this rule. Okay, nothing else. Okay, I will end here. In the next video, we will continue 5.1.